A child fell in an open roadside drain hole. His father asks a worker for help, so he goes there using a worker's manual and reaches him. Disgusting as it may seem, let us look at it the other way. The place where you fell is a destination. The worker had to travel all the way down at his regular speed, but you reach there in hardly any time on being pulled in by the force of gravity. That's how a wormhole works, although its formation is a bit too complex depending on its type. Here we are mainly looking at the Einstein-Rosen Bridges or the Schwarzschild Wormhole. Wormholes can help us to connect to very distant points in the space-time fabric by forming a tunnel in between. We are familiar with a black hole. Its mass is concentrated at a single point called singularity that warps space-time so much that it collapses into a hole, which anything can enter but nothing can escape. This point seems to be a dead end, but there's a possibility that there is no singularity here. Rather, this funnel further stretches down and opens up into a parallel universe. Mathematically, we can show it by reversing equations. This new version will now of course work opposite to a black hole. Things can only exit but nothing can enter. As you may have guessed, it's called a white hole. We can join these two to have a Schwarzschild wormhole. But the issue is that these wormholes are not stable. They are pinched close by gravity the moment they are formed. Traversable wormholes have to remain open, and for that we need something to defy gravity. That is negative energy. But how? In Einstein's formula of E is equals to mc square, c is a constant and cannot be changed. On making energy negative, mass would also be negative. This is called exotic matter. Things with positive mass warp spacetime around them and are attractive. But negative mass would create an outward bulge on the spacetime fabric and would be repulsive. Hence, they can be used to keep our wormholes open. Presently, exotic matter is a hypothetical idea. In fact, it even violates the general theory of relativity. Well, does that mean traversable wormholes would always remain a dream? Actually, it's way too early to answer that question. With advancement, exploration, and re-evaluating our existing theories, we may one day be able to make traveling to faraway galaxies as simple as walking to the house next door.